Hello class, today's lesson is in chapter 1.8. It is on the powers of 10. You all are kind of familiar, you're at least familiar with working with exponents from our cognitive cardio class that we do. So powers of 10, we are working with the base, which is this main number here, a base of 10, and we're putting an exponent to it. So this is something that's easy to memorize. I highly recommend you memorize this. So remember, anything to the 0 power is 1. So we have 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000. Are you guys noticing a pattern here? Notice that the exponent is telling you how many zeros you are going to add to your 1. 10 to the fourth power is 10,000, 10 to the fifth power is 100,000, and 10 to the sixth power is 1,000,000. So powers in which the base is 10 have many important uses in mathematics and science, which is a really excellent reason, good reason for you to be familiar with the powers of 10. Here is a chart that extends from 10 to the 0 power all the way to 10 to the 14th power. You can see we go from ones to thousands, millions, billions, and trillions. And one day you will work with exponents that are this high. Okay, I'd like for you to copy this chart. We are going to work a few examples, and I'm going to go to my whiteboard. Okay. So I'm going to do 12 times 10 to the third power. This is example 1 in your book. So basically what we're doing is 12 times 1 equals 12, and then we're going to add 3 zeros. 1, 2, 3, for an answer of 12. Ooh, that is really messy. Sorry about that. 12,000. I'll try to write better next time. Okay, the next example is 275 times 10 to the fourth power. So you want to multiply 275 times 1 equals 275. And then we're going to add 4 zeros. 1, 2, 3, 4. Put a comma after the third number or third digit for a number of 2,750,000 and box your answer. Next example, 4,806 times 10 to the second power. So this is 4,806 times 1, which equals itself. And then we add 2 zeros. I go over 3 digits, add my comma, and there's my answer. 480,600. Okay, last example. 7 times 10 to the 0 power. Do you remember from our cognitive cardio, what is any number to the 0 power? Okay, let you say it out loud. I'm sure you said 1. Okay, so it's 7 times 1 equals 7. Okay, I'm going to do a little problem for you. Let's clear this board. Let's say that you wanted to earn money and you wanted to work in the yard, do yard work, for $5 a week. Okay. You're going to do this for your neighbor because you're just such a kind neighbor and you don't want your neighbor to have to go out in the heat. So you're going to mow their yard for $5 a week. Okay, in 10 weeks, you would make a total of $50. And you probably could do that math fairly easy just looking at it, but I want to show you how you can do this math when you break it down in a base of 10. So in 10 weeks, that would be 10 to the first power. We multiply that by 5, we get 50 because 5 times 1 is 5, and then we add 1 0. Now, what if we want to know how much you'll make in 100 weeks? Okay, so now we're going to do you remember what exponent do we need to have in order to make 100? What exponent would I put here? If you thought 2, you are correct. So this would be 10 to the second power times 5. So we want to multiply 5 times 1 is 5, and then add 2 zeros. So you would make $500 in 100 weeks of yard work. Doesn't that sound like fun? Okay, now if you were really committed, what if you worked 1,000 weeks? How do I make 1,000 with a base of 10? I'm going to put an exponent of 3 because 3 zeros after a 1 make 1,000. So 1 times 5 again is 5, and we add our 3 zeros. That is $5,000 in 1,000 weeks. Okay, hard work paying off. So that is my examples for you this week on the basis of 10. If you have any questions on your homework, of course, drop in with me, and I will see you guys next lesson.